Guys, language keeps improving as you use it. It's just like right in front of your eyes, magically becoming better and better and better. You don't even have to wait for releases or anything. It's amazing. Can your Zig do that? Can your Odin do that? I don't fucking think so. Can your C do that? Motherfucking C can't even finally finalize the embed thingy. They still don't have it final. Maybe they already have it finalized, but I don't really know. But I mean, it's so slow. This thing right in front of your eyes, getting better. Alright, chat. Do you remember this little thing? The panim? My attempt at implementing manim, but in C. And it went quite successfully, right? So I just didn't have motivation to sort of like make a video out of that, but maybe at some point I'm gonna resume my work on that. So panim is essentially consists of just a single executable, right? And a bunch of DLLs. And each animation is a DLL, sort of like a plugin that you run with the executable that is an engine, right? So if you build this entire thing, you're gonna end up with something like this, right? So in a project, we have the executable, the engine itself, and a bunch of SOs. Right. So I only developed it for Linux. Potentially it may work on Windows, but I never really tested it there. I don't remember if I use anything Linux specific. Well, I mean, I do use Linux specific DLL stuff, right? So, but I mean, it's equivalent to something that you can find in Win API anyway. So it shouldn't be that big of an issue to port that to Windows. Right. And the way you actually work with that is essentially you run panim, right, and it expects you to provide the DLL or SO. So, and the animation we can provide in here is, for example, something like this. So here is the Turing machine, the animation for a Turing machine. So it looks like this, right? And it even has sounds. Look at that. It even has sounds. And it's all procedurally generated. It is all procedurally generated. I can actually stop this entire thing. I can speed up and or slow down. There's some other things. Look at that. I think it's adaptable even to some extent. Well, I mean, yeah, not really. Right, and I think there's some ways to generate videos out of that. So I don't remember all of the keys. I should have implemented something that actually shows all of the keys. So yeah, I think it's something like render. Maybe it's the key just R, but it's kind of hard to tell. Yeah, there we go. So rendering. So if we're currently rendering with not rendering. Yeah, so it's essentially R. If you press R, it will start actually rendering a video. Right, and it will render it using, I'm pretty sure, yeah, it's just using FFmpeg. So it's just like piping all of that stuff into FFmpeg. I don't know how long it's going to do that. It's doing it relatively slowly. Probably because the frames are generated really slowly. So essentially what we do, we just render this entire thing into the frame buffer, right? And then just pipe in all of the frames into FFmpeg and it's already done. Right, so here's the video, and then you can use that video in the video editor, right? So it's MP4. Right, so it doesn't include the sounds apparently. Maybe I forgot to enable that, but anyways, so it's also supposed to include the sounds. Right, and the thing is, on one of the previous stream, I think it was like literally the last stream, literally the previous stream, we were working on futures in C3, right? So it's already on YouTube as far as I know. So Tsoding daily futures, right? So it's this one. It's this video. Right, and we implemented it quite successfully. So the abstractions and the features of C3 make it relatively easy to implement your own features. And funny things, oh yeah, so here it is, features in C3 video, right? So, and here is, by the way, the you know, the source code of the features. We'll need it actually in here. We'll need it in here. So the way we implemented the animation, we actually implemented something resembling futures, but in pure C. Right, because this is a rather complicated animation if you look at that, right? It's a rather complicated animation. There's a lot of things in here going on, right? And a lot of things that are parallel and stuff like that. And some of the things that are similar to each other. And the way we implemented that, we introduced the notion of a task. Right, and a task is something that you have to poll on each frame. So, and essentially you can have several tasks in parallel, Right. For example, just right now, this thing started to like have an effect, and this thing went up. These are two separate tasks that are pulled simultaneously and animated simultaneously. Right. So, and this is how the entire animation is composed. It's composed out of these tasks that act like futures that we implemented on the previous stream. So, which led me to an idea. Can I just use C3? Because doing futures like that in pure C, it's kind of a pain in the ass, right? I remember that being pain in the ass. So let me find, so tasks. Yeah, there we go. Here's the some task, right? So, and essentially you have tasks like write head, move head, which is the head of the Turing machine and stuff like that. You can combine them sequentially and stuff like that. And you just like combine this AST, and it's kind of painful. In all honesty, it's kind of painful. And this is because you can't really implement proper future in C syntactically, at least. It's kind of difficult. So I thought maybe I can just do that in C3 and see if it's comfortable or not. Luckily, since the animations are basically DLLs, you can implement animations in whatever language you want. Right, you can implement them in whatever you want. Whatever language allows you to create a DLL with a C call convention, you can just use that, right? So essentially C is a lingua franca of programming world. Everything is C. Whether you like it or not, underneath everything is just C, right? So C is the programming language of planet Earth. And I'm not trying to diss anyone or whatever, it's just like I'm stating facts. This is just a fact, right? If the fact offends you, sorry. So C is the programming language of planet Earth. It's too late to change anything. So, and because of that, I think we even had some of the animations written in C++, didn't we? I don't remember actually. I think at some point we tried to do that, but I don't remember if I actually committed any of them. Oh yeah, there we go. So we have a, yeah, so we even implemented sort of like tasks in C++. There we go, and they're also pollable. Look at that. So here is the update with the environment and stuff like that. There you go, there you go. And it's actually a little bit more comfortable in C++, I think. Yeah, the way you construct them is, here is your sort of like a, tasks, and you combine them sequentially, and they do different things in here, right? They just do different things. So this is in C++, and then it's compiled to DLL and everything. We can even try to run this kind of stuff. So I think it's just libprob. There we go. Oh yeah. Okay. Oh, I accidentally rendered it. I don't remember how to restart it. So does anybody remember how to restart it? But yeah, there we go. So you can implement this kind of stuff in C++. So you need sort of like a native language that can compile to DLL and can also work with the Raylib. So which means C3 could be potentially a good candidate. So the only problem I think I remember from this C++ is that it was not possible to hot reload virtual methods. Because remember why? So like this thing has virtual methods, that's for sure. And you can't just hot reload the DLL. DLL is also supposed to store the state of the animation, right? And essentially, the objects, I think, they stored like a pointers within the virtual table, and the virtual table was within the DLL. And if you reload the DLL, the virtual table sort of pointers become invalid, right? So, and because of that, you couldn't hot reload the C++. As far as I know, C3 interfaces and dynamic methods are also kind of implemented like, virtual tables. And the question is, will C3 actually survive the hot reloading of panim? See, if I remember correctly, it was a long time ago. I think C++ couldn't survive that. But C3, I don't know how exactly it is implemented, maybe it can. So the only way, as far as I can understand, to survive hot reload is to be able to patch up the virtual table, right? So, and you can't do that in C++ because the exact implementation of the virtual table is sort of like a implementation specific, right? So it's not standardized. The compilers can do whatever the fuck they want. And so does C3 have any access to its virtual table or whatever mechanism it is using? That's a good question that I would like to maybe try to answer today. So, sounds good. Sounds Gucci. Sounds Tamaguchi. Let's fucking go. So the question is, how the fuck do you create a DLL in C3? I have no idea. Right. So I think this is the first thing that we're going to try to do. C3 SO DLL. Right. So let's actually go ahead. So if I create like hello world, right, we're going to start with the hello world just to check that the latest version of the compiler that we pulled recently still works. It still works and all the jazz. Print fn. And I'm gonna say hello world, right? And I don't really have to return anything. C3C compile run main C3. There we go. And the question is, how the fuck do you even generate a DLL? Do you have anything about that in the help, for instance? So something about the library. Okay, so you can init lib, right? So. So there's a lib name. I suppose what we have to do. So library. It's a link with the library. So maybe shared. Initialize a new library structure. So you can actually maybe create a project. I don't like this init command, chat. I really don't like this init command. So you just do init and test, right? And it generates you a huge slope of a template project that includes literally everything. Everything that this entire thing supports. And it's just like, ew, brother, ew. Like, it can be potentially probably very simple and very, like, you know, tidy and neat and stuff like that, but it's just like, I don't know what I can remove from here. Like, why the fuck do you give me everything? It's just like, no, this is just like scary. Look at this, like, get away from me. Like, I don't want to even look into that. So, and I suppose, yeah, so you can build libraries, right? So, but you have to do that through their slope of, seriously? What the fuck? Like, I'm not gonna be compiling for FreeBSD. I'm not gonna be compiling for RISC-V. Like, why do you give me all of that? Like, this is not a good way to introduce users to your build system. Like, this is not a good way to introduce that. Right, so you just don't dump everything on a user who doesn't know how to use your build. You just don't fucking do that. You have to introduce that incrementally, slowly. Right, it's just like, it doesn't make me want to use that, right? I just want to build a library, bro. Like, I'm not gonna be playing it like Mac OS, Arch. Are you serious? Scripts? You need some script. It's just like, it looks like a slope. It's not a good look. Like, I'm pretty sure Lerner actually values simplicity as much as I do. Like, I know that. He's a great software engineer with a lot of experience. Like, I understand how he views that. But it's just like not a great way to introduce the user to your build system. And I'm pretty sure it's very simple. But it's just like, I don't see that. Just show me the simplicity. So far, I just see a slope dumped onto me. It's just, nah. Oh, yes. Get away from me. Right. So, and because of that, I just like try to move away to compile. Right, so maybe we can, I was using compile run, maybe just compile, right? Maybe just compile. And right away, I don't see how to create a library, right? So you can compile, but maybe you can do something like, okay, C, minus C. Right, it's not minus C. Okay, library. Oh, I see. Oh, okay. Compile files without the project into a dynamic. Perfect. This is what I'm talking about. Dynamic lib main C3. Okay, failed to find C runtime at link time. Okay, how... When was the last time anybody tried this command, by the way? When was the last time anybody tried this command? Does anybody use this command ever? So main.age. Okay, brother. Okay. So let's try one more time, but with a passion. Just a simple hello world simply doesn't work. And it doesn't even explain to you how like what exactly you did wrong. It tells you I couldn't link anything. Sorry. So it wants a C runtime. Okay, let's link with C. This is not how we link with C. Okay, so link with the library provided. Okay, so maybe the thing I have to do in here is just like a C. I have no idea. Something is broken in this specific part of the compiler, and I suspect due to not that many people using it. So I suppose a lot of people just compiling executables and stuff like that is just like ZLC. Maybe this is what we have to do in here, and it didn't help. Okay, something apparently broken. All right. So, but we're engineers. We're not afraid of that. Dynamic libraries. Do you have anything? Library packaging. Okay. So library packaging. How it works. So this is macOS. I'm not a macOS user. I'm sorry. I don't care. I'm sure it is simple. I'm sure it is simple. But I think C3 just fall into the same trap of as Swift, right? Instead of showing off its simplicity and being proud of it, like loud and proud of simplicity. Here you go. This is how you make a DLL with a single command. They go this, oh, here's everything that this can do. Figure it out. Figure it out yourself. Like, bro. Don't make me so disappointed. Don't make me so disappointed. So, anyway. How can we approach that? Like, I don't even know what is going on and what exactly doesn't want. What exactly does it even mean? So, what if I just get rid of the I.O.? I.O. Like, I'm getting rid of the I.O. completely, right? I'm removing everything related to just O, right? So, okay, so it also generates a bunch of C. I suppose maybe it uses C as the sort of like a backend or something. And if I try to just make a DLL, okay. Still didn't work. Okay. Oh boy. So do I have to no standard library? No. There was something about like a no libc. Do you guys remember? Do you guys remember like libc? Oh, okay. So what if I just say, bro, do not link with libc, right? Do not link with libc. No. C3. Unable to find library. How does that make any fucking sense? So there is an issue where you can see some of the available commands regarding CRT std issue. So it's not even fixed yet. I didn't expect to encounter some unfixed compiler bug, just doing a simple thing. Okay, so I'm trying to build a dynamic library from C3. Just as we are trying to do that. And then link it with C3 executable. The executable is compiled and linked successfully, but hangs indefinitely. This is not our case, right? So this is not our case. Okay, so this is just a compiler. Links here. Like, how am I supposed to know this thing? CRT, dear. Why can't I just do dynamic lib and just fucking build it without knowing any of this flag or anything like that? I'm not using any special environment like WASM or anything like that. Why can't I just dynamic lib and just get a dynamic lib? I don't understand. This is a bug. This is a usability bug. This is a usability bug. How are you supposed to replace C if you just like, what the fuck? Excuse me. Bro, this has to be fixed ASAP. This has to be fixed ASAP. This is like unacceptable. Anyways, so if I try to build C3, so let's take a look at what this thing does. CRT, WinCRT, Linux CRT, set the directory to set. Bro, like, I mean, it's the same literally everywhere. It's the same user lib. Are you serious? Like, bro, this is your job to know that. Not mine. Why do you force that on the user? This is not my job to do all of this. Like, seriously? Why the fuck do I need a compiler if this is the stuff I have to do? It's like, seriously? Anyway, I'm sorry. I'm just like, I'm so outraged right now. Like, why the fuck do I have to even do that? Are you compiler or what? Are you just, what the fuck? No files. Yeah, okay. I mean, if you claim to support Linux, you should know that on 99.999% of the Linuxes, this is where you find the fucking libraries. This is just like a standard at this point. Just hardcode that. Don't remove these flags or anything like that. Just let it customize and stuff. But fucking put it as a default value or something. At least have a little bit of respect to the user. Like, what the fuck? This is just like outrage. Like, I'm sorry. It's not even that difficult of a fix. If this is everything it takes to create a DLL on Linux, if def __ Linux __ set default Linux SRT user lib. Right, don't remove the flag, just have a default. Anyways, sorry. So it created a bunch of things in here. So right. So if I create something like this, okay. So and it also creates H, which is rather interesting, right? So I suppose it creates this header for you to call this sort of like a library from C. This is actually rather interesting. So let's actually do the following thing. How can we call our library? So let's call it something like test, right? So this is going to be test library, and it's going to have some things. For example, let's call it add int x and int y, and we're going to just return x plus y, and then we're going to have something like sub. Right, so it's going to be sub, and this is going to just basically subtract them, nothing particularly special. So as far as I know, you do extern, and you just say, maybe it's enough to just say that those things are external, right? So let's do external. Excuse me. And this is going to be test, and this is going to be lib test. All right. So what I have in here, external function. I see. So can I just have something like this and not provide any stuff in here? All right. So something like this. Right. So that means I have to provide the name of the function. So I was hoping that maybe it will just pick up this name and use that as the symbol, but no, you literally have to provide it. Not that big of a deal. Not that big of a deal. So this one is going to be add. And there we go. So, and it created, I really like this thing. I really like that it generates the header, but I think it's kind of flawed. Why didn't it generate the external functions? Can anybody explain to me, like, why it didn't generate? Is it supposed to generate external functions? Or does it just like give you this sort of like types in case you like? I'm not even sure. I'm not even sure. It's kind of bizarre to me. So if I take a look at nm in here, so do I have things like add? It's kind of difficult to find, right? So because the word add, so let's call it test add test sub, right? Test add test sub. Right. So and then if I go here, right, test add, it's not even available there. Extern export, probably. This is probably what I had to do. Export? Is that how you do that? Not extern? Okay, so that seems to be working. Oh, finally, and now generate. Okay, I really like this idea, honestly. I really like this idea of generating like headers for C. Right, to just like basically describe the interface of DLL. I think it's kind of cool. Right, so now that means we should be able to just like use this library in here, right? So it's actually a really big library. Like, I suppose it includes the entirety of the C3 runtime and stuff like that. And if I take a look at this stuff, also here they are. Here are all of these things in here, so that makes sense. So that's pretty cool. That is pretty cool. So let's actually try to create a C thingy, right? And in here, we are going to include this thing. We're going to include this thing, and in here we're gonna just like do printfd test add 34 35, right? And we're gonna try to build this entire thing main.c, and we're gonna link with test. So it's not so you have to search for this thing in here. Okay, so and we created main, and we just it couldn't find that, right? So because we have to search for ld library path like so, and it worked, right? So as you can see, it's 69, and we successfully called C3 code from C. All of that is so freaking cool, but that usability bug where you forced to do that Linux CRT flag, this is bullshit. It really hurts the promotion of C3, right? Imagine how cool of a demo this was if this entire thing was just as intuitive as just dynamic lib, compile that, and you get SO and a header file, you include header file in C, link with the library, and it just works without any Linux. Like, just think how cool that would be. Zeke and Odin would be in fucking shambles. Like holy fucking shit, I just compiled it without any bullshit, without any fucking flags, and it just fucking worked, like holy fucking shit. And it's so simple to achieve that. It is such an easy fix, like a low effort fix, but the impact is just like holy fucking shit. It's just like you show that in demo, and all of the VCs are throwing money at you, like holy fuck. Usability. I'm sorry, I'm a little bit emotional. When I see this kind of stuff, it's just like angers me. Anyways, so we can just create like DLLs and stuff. Time to get rich, Mr. Zozin. Yeah, exactly. Fucking all right, so I'm really glad that it's super easy to create DLLs and stuff. So I suppose the time has come to actually create a simple animation in Panim, because on top of Panim, right, so it's a little bit more complicated because you also have to link with Raylib, right? So the whole architecture of Panim looks roughly like this, right? So this is going to be Panim, and that Panim thingy is going to be a square, right? So by square, I usually mean executable, right? And you have Raylib, which is a SO file, and it's going to be ellipse, and that means it's a DLL, right? And Panim just uses this DLL. It calls it like that. Then you have your animation, right? So lib, not lim, but lib, anim, which is also SO. And it's loaded dynamically into the engine. So engine uses both your animation and Raylib SO dynamically. This is very important. But on top of that, your animation as well uses the same Raylib. That's how it works. So essentially, Panim organizes a loop, event loop that constantly does begin drawing, end drawing, and between begin drawing and end drawing, it calls your function update frame, which uses the same Raylib to draw that frame. So essentially, the engine and your animation using the shared state of Raylib to do all of the drawing. So that's how it works. So what we have to do in C3, we have to create the NSO file, and we have to also link with the dynamic Raylib. So to organize this sort of like architecture. Does that make sense? I hope that makes sense. And what this allows you to do, it allows you to hot reload your animation, right? So for example, you updated it and recompile it, you ask Panim engine, please reload this entire thing, it unloads your thing, then loads a new one, right, and continues without stopping. So that's how entire thing works. You know, the classical hot reloading thing. Nothing particularly special. So now what we need to do, we need to write this thing in C3 somehow, right? So let's go ahead and do that. So now we know at least how to do that. So tsoding panim. All right. So panim is using knob for building, right? And here we have a bunch of things. Okay, so this is how we build the plugins, right? So we have C plugins and we have a separate thing that builds C++ plugins. And I suppose what we need to do in here, we need to do something like a build plug C3, right? So force, what the fuck is force? Is that a flag? Ah, I think that's kind of funny. So knob has minus, like this specific instance of knob has minus F flag, which forces rebuild, because these things, they check whether it needs rebuild or not. But sometimes you want to force rebuild all of them, and we'll actually do that through this sort of flag that is passed around. That's kind of funny. So because if I try to just do knob like so, right? So then I can do minus F, and it rebuilds all of them. Right, so yeah, they take a little bit of a time to rebuild. That's probably why I don't rebuild them every time. Right, so that makes sense. Anyway, so let's actually maybe create a similar thing. So src dir, where in the source we're going to have, how should I call that? I don't know, so let's call it prob2, and it's going to be C3, right? So because for C++ we call it just prob, this one is prob2, C3. Right. So, and in build dir, we're going to have a lib prob2 so, and then if it didn't succeed, we just return, you know, 3 in here. So I suppose what we're going to do in here, we're going to just like copy paste existing function, right. So build plug C3, and here is the signature. The force flag that rebuilds everything, the command. Command is just like a dynamic array of the arguments of the command line and stuff like that. The path to the source code and the output, the path to the output. So that's what it is. So here's how we check in that something needs to rebuild. So we have a function in knob that given output and input, it answers to you whether it needs to be rebuilt or not. Right, so the way it does that, it just compares the modification dates, nothing particularly special. Right, and it returns you three values. It can be 0, it can be 1, it can be -1. In case of -1, an error has happened. In that case, you just have to return with false, because the error will be logged automatically by this function. Anyway, you don't have to say anything, you just have to say, you have to just return out of that, nothing particularly special. So, and then, if somebody defined force, you rebuild anyway, regardless of this thing does, right? So that's how we do that. You see, very simple and straightforward stuff. Very simple and straightforward stuff. Oh, here we are cleaning up some stuff, right? So we kind of assume that CMD may be not empty. Yeah, that's kind of funny. Right, so we don't really have to do that anymore, because recently in knob CMD, we introduced a very cool function, which is basically like this, CMD run async, and it's called end reset, right, end reset, and it actually accepts CMD by a pointer and resets its value, cleans up, so you can reuse it yet again, you know, successfully. So I think this code is rather old. It was written before I introduced this run and reset pattern into knob. And by the way, one of the reasons why I introduced this run and reset pattern is because I was kept doing this kind of shit where I had to make sure, okay, the count of the CMD is 0 all the time. Well, I mean, you always want to reuse it after you run it. So that's why we have run and reset. So I think it's much better pattern in my opinion. So in here, I'm going to just like reset it just in case, because the rest of the code kind of assumes that it can be not empty, right? So just like let's reset it just in case. And in here, let's start creating the command line, you know, command line arguments, right? So here we're going to have C3C. So then we're going to do dynamic lib, and we have to do this Linux CRT, right? And it's just user lib, like this, like user lib. For the output, we're going to use the output path, and for the input, we're going to use a source path, right? So that's basically what we have in here. So it doesn't really have to be like this. And after that, I think that's it, right? So on top of this, I think we have to link with the raylib, right? We kind of have to link with the raylib. We already have some code that adds flags for linking with the raylib, but it's only for C. Because of that, I think I need to actually call it something like C, right? So because these flags are not suitable for specifically C3. Right, I think it does make sense. So, but anyway, let's actually try to compile this entire thing and see how miserably it's going to fail, and just go through the compilation errors. Right, so yeah, it doesn't have libs, so it has to be libc. Anything else? Another libc situation, another libc situation. There we go. So, and something went wrong, and I don't know exactly what. This is probably because I forgot to return that I successfully did this thing. So, and furthermore, I didn't even run the command, right? So I should have done a cmd run sync and reset. All right, so this is going to be cmd. If not that, return false, right? So that's how we're going to be doing all that. If I try to rebuild that, oh, I'm using old knob. This is such an old project, like I should have expected that, right? So the new features in Knob, they are not even there yet. So this is one of the cool things about Knob, right? Is that it kind of never decays. Well, I mean, you just saw it decay a little bit, but it doesn't decay in a different sense. In the sense that if you're using something like CMake and or Auto tools to build your project, over time, if you don't update the configuration of your project and stuff like that, the newer CMake and newer Auto tools will not be able to build your project. Here, if you're using Knob, you actually use the older version of Knob. You actually commit the older version of Knob into the source code. So that means it doesn't matter for how long your source code ferments, you always using the relevant version of your build tool, because build tool is part of your source code. This is actually something that a lot of build tool developers really fucking neglect. It doesn't bitrot in that sense. It bitrots in different sense, but it doesn't bitrot in that sense. Right, so it just simply uses older version of Knob. Right, it just uses older version of Knob that only depends on POSIX API. So it bitrots as fast as POSIX API. And POSIX API, by the way, bitrots very slowly because it's standardized, and a lot of very powerful entities all around the world depend on POSIX being stable. And by very powerful entities, I mean corporations, governments. And those entities are not a fucking joke. They are putting a lot of their influence, a lot of their money into maintaining this API being stable. If you depend on, for example, web APIs, only the web corporations like Google use their influence and money to keep them stable. But the influence and money of Google are pretty shaky, because more powerful entities like government can always fuck up Google at any time, which they are currently doing. Antitrust situation, right? So, but nobody stays above the governments, right? So if the government maintains a certain API stable, you can be pretty damn fucking sure that it's gonna stable. If Google maintains some API stable, well, maybe it will survive for like 10 years, for 20 years max. But then Google is going to be ripped apart, Chrome is going to be ripped apart from Google, everything is going to fall apart and everything. It's like nobody knows what's going to happen. POSIX is pretty good fucking damn stable. You know what I'm talking about? You know what I'm talking about? You know what I'm talking about. So yeah, fuck Google, by the way. Only God stays above the government. Imagine an API maintained by God. Guys, I think I know the answer. We should write for TempleOS. We should write for TempleOS. It's API maintained by God himself. Even the governments can do anything to TempleOS. Like, it's just like, it's the God himself maintains this API. I'm telling you. Anyways, so let's go ahead and update Knob. If you want to actually use Knob for yourself, which I don't know if I recommend, but I mean, it's kind of a very special thing, right? So for a special mindset, I would say. So, but I'm going to put that in the description just in case if you want to play with it, right? So here is the knob.h. Right, it's kind of like, yeah. So you need to be like a simplicity junkie like I am if you want to use knob. But it's pretty usable. It's pretty usable nonetheless. So knob.h. So let's actually download this mother flipper. Let's do a row. Let's row dog knob. And I'm going to just like literally duplicate it. I think I have to do that in SRC. I'm pretty sure about that. Boom. So let's see how many changes were up. Okay. So wget does not replace things. Look at the difference. So this is old knob. This is the new knob. The bloat is creeping. The bloat is literally creeping. So if I do that, and we can even take a look at how many changes were made since then. Yep, that's a lot of changes. But it should be kind of backward compatible. I don't think I introduced anything like super backward incompatible, so I'm pretty sure it is going to just work if I try to do something like that. And it kind of did in fact work, right? So it kind of did in fact work, but the compilation has failed of C3, right? Because we didn't have the file knob2c3. prop2, not knob2, right? So we can do something like touch. We can touch this file. We can rebuild it. Yeah, there we go. So it still works. You see? So the size of the knob increased twice, but it's still backward compatible. I just copy it to the older project, and it just works. So, but now it also has additional features. We're trying to kind of maintain it backward compatible to some extent, as much as we can. Right. So as much as we can. So. So did it create a source? Fuck. Why do you append .so? What kind of Windows brainworm is that? Excuse me. Needless to say that C3 is kind of rough around the edges. The general direction is kind of correct, but sometimes some of the like very specific small little thingies is just like, why is it like that? But again, as I already said, probably not very many people are using this language, right? So that's why not that many people bump into those things. So yeah, okay. So that means we should not put a so in there. Which, by the way, wait, I just realized that it could be actually based. Just a second. It could be actually based. Right, because that means on different platforms, it's gonna pick a different extension, so you don't have to if-def on different. Okay, this is actually based. Jai does that. Okay, this is actually based. It's just like me being dummy. Okay, so I take everything I said back. So this is based actually. This is based. All right, I agree with that. Okay, sure. Fair enough. So let's actually rebuild everything. Okay. All right. So yeah. Looks like it is working. Looks like, and there we go. So it also built header in here. It would be interesting. Nah, so I was thinking maybe I should, I want to put the header somewhere else, but I think it's fine the header being here. But I don't really plan for that header to be used anywhere, because the C already knows how to interact with these plugins, because we already have a header for them. So here's the header. This one. And that means we need to implement all of these functions in C3 to be able to load these things. So we can even go ahead and try to already load the plugin we created in C3 into Panim and see how miserably it's going to fail. So let's do build Panim and build libprob so. There we go. Undefined symbol main. Why the fuck were you trying to load main? What? Alright, so main? By the way, who said that? Who said main? Is that Panim who said main? Why were you trying to load main? Okay, that's bizarre. So let me take a look at what we have in here. Wait, it could be actually bug in Panim. Load symbol, so reload libplug. Right, and it doesn't have anything hard-coded. Here's the thing, it doesn't have anything hard-coded. What it does, it just like opens it up and it iterates through all of the known plugins and just like DL sims them and then just like asks DL error. So new backdoor just dropped. Maybe it is a backdrop of some sort, who fucking knows. Plug.h, and yeah, so that's the only thing that we're trying to load or anything. So, and also we accept the environment by a value, get fucking damn it. So I don't think it's a very good idea, right, especially for interrupt. Okay, so before I define all of these things, what if I go ahead and just literally create main, right? So main, and I'm gonna export this main like so, right? So, and then just not gonna do anything because I wonder if you want to load the main function, let's just let you load the main function and see what happens, right? If that's what you want, right? So, okay, that's very interesting. So now it wants a plug in it. And before, it's the C runtime looking for main. That's a funny hypothesis. That could be a case. That means that this error will happen if I just do DL open of that is so. I need to test that. Like, this is a mystery. Like, this is enigma. I want to investigate that. Like, what the fuck is going on in here? I think it works by creating DLL ISO file. Oh, you guys talking among each other. I'm sorry. Yeah. So it's something directed to me. So because it links with it also links with CRT and shit. It's freaking fascinating. Anyway, so let's just literally try to load DL open that file in C and see what happened. Right. So how do you do man DL open? Right. So man DL open, and let's just put it in here. So we also have to put some flags in there. And I think it's something, or yeah, so it's whether you want to load them now or later. And this could be the key to our struggles. So there's two flags in here, which is lazy, resolve symbols only as the code that reference them is executed, and now resolve the symbols as like all of them as soon as possible. Maybe, yeah, so maybe you need to put lazy so it doesn't try to eagerly resolve main or something like that. I think we're learning something. I think we're on the right track to learn something new in here. I really like that. I really like when you discover some shit like that and you just actually learn something cool. Right, so this is going to be just build and then libprob2 electric boogaloo. Alright, so and then here we have lib, and if lib is equal to null, alright, we're going to do something like std error. Let's actually do something like a file path, const char file path, like so. We don't even need that, right? So could not load s, and so here is file path, dl error, like this, and we just return 1. Otherwise, we just do printf, okay. Maybe even print the whole thing, maybe even call it in 4 for the consistency. Yeah, and in here we can put a new line, file path, new line, let's fucking go. So cco test c, and let's do test. So it didn't work because you also have to include this thingy in here. Let's fucking go. Boom, it loaded successfully. This is because main was present there. So now if I go to here and remove the main and recompile the whole thing, not really like that, but just, you know, knob recompile, and then look at that shit. Fascinating. DL open expects you to have main, and if you compile DLL with C without main, it will still add that fucking main. Does it call this freaking main? So prob2, I'm gonna do a then void main export main import stdio print fn hello from c3 like so. So let's do, this is not really what I wanted. I wanted to just do knob. So I forgot the semicolon, the proper semicolon. Could not be found. Did you spell it print? Didn't print anything though. It didn't actually call it. It just loaded it. It simply loaded it. So now, yeah, I was hoping that maybe it will like literally call it, but it didn't. So because maybe it like expects initialization or something like that, right? So because in ELF there is sort of like an init function of like ini and fini. I thought it's somehow related to that. So because it probably has underscore start and init code, but nothing calls the code. Yeah. So here's the another interesting thing that we can try. So I'm going to not export this entire thing, right? I'm gonna just like do it like that, which will probably mean that it's gonna get optimized out. It didn't get optimized out, so okay. All right, so it doesn't exist anymore. And now in test, I'm actually using lazy. Even if you use lazy, it's still gonna try to load this because it actively tries to do that. So the DL open really wants main. It really wants main. So, and another interesting thing, okay, so let's take a look at things that are written in C. So this thing is written in C. If I take a look at the external symbols, does it have main? It doesn't even have main. It doesn't even have main. I think CRT0 wants main. The one that you actually link with C3. C3 has a special init and fini stuff. It's pretty cool. So that means you telling me that C3 potentially generates some code that also wants to dynamically load main or something. Is that what's going on? And it doesn't even call it. It's probably an accident. Maybe we discovered the start in CRT1 wants main in C3 linked with underscore start. Can you compile this stuff without, well, I mean, maybe it should have actually linked with a different thing. And let's go start in C3 wants main and C3 links. So what's the solution in here? So whose bug is this, chat? Whose bug is this? Is that our bug or is that C3 bug? I have a feeling that it's a C3 bug, so they maybe linked with the wrong CRT thingy. They might have actually linked with the wrong CRT. So when you're creating DLLs, with which CRT do you have to link? Do you have to link with CRT at all? Should not link with CRT. Okay, so the question is C3 dynamic lib help. So CRT, WinCrt, set the directory to use for finding CRT begin and related. Can I just say no CRT? So there's an libc thingy, but I don't want to do libc thingy. Maybe we're holding it wrong kind of bug due to that atrocious command line. No entry. Bro. No entry, no. Okay. One more time. All right. So we have this kind of situation. Now, I'm going to here. Nah, it didn't help. It didn't fucking help. So no entry didn't help. So yeah, it needs the C runtime. So don't link CRT when using no entry. Maybe. All right. So let me go to third party here. Can I just grab the CRT1? Well, we can already see some interesting stuff. So what do we have in here? So this is just a build. How can I like exclude dir build? Yeah, there we go. So this is that. Set the directory to use CRT related stuff. Okay, so find lib FreeBSD. That's understandable. Linux CRT. Okay. So there's also this thing. This one is kind of weird. Linker setup Linux. So CRT1. SCRT. Position independent and stuff like that. Yeah, there should be something done with the linker, but I don't really want to mess with that right now. I really don't want to mess with that right now. No stdlib also we have a lot of stuff right here. Yeah. Userlib, by the way. Userlib. Anyways, I guess one could pass the path to an empty CRT10, but like who does that? Well, yeah, so I was thinking maybe I can hack the compiler to do something about that, but it's not really that important. All right, we're back. Internet went down again. Get used to that. It's gonna happen every single stream at this point, so whatever. So we already have a way to reproduce that, I think. I think we already have a way to reproduce that. What we can do, so to not forget, we can just report an issue right now. I think that's going to be a good idea, chat. I think that's going to be a good idea. Let's actually report it as an issue. So yeah, so probe C3 DLL bug. It's actually really easy to reproduce, right? So this is going to be lib C3. And it's going to be literally empty, I think. It's going to be literally empty. And in here, we have a load C, right? So here is just a load C. And I think I'm going to do something like this. I'm going to just literally copy paste the whole thing in here. And so here we're going to just do libso, just libso. File path DL error. And it's kind of important to, I think, to do that on Linux. All right, so the way we reproduce that is run sh, binsh, so C3C compile run dynamic, I'm sorry, dynamic lib, Linux CRT user lib, O libc3. Right, so let's actually enable maybe tracing for now. So let's make this thing executable. And yeah, it created the thing. And on top of that, what we have to do, we have to also compile this kind of stuff. So load.c. So if I try to do that, it seems to be working. So if I do load, could not open because we have to do that from here. And let's do run sh like this. Yeah, so that's pretty cool. So that's the reproduction. So let's go to C3 lang, C3C. And let's try to do this kind of stuff. Okay. So what exactly does it say? Undefine symbol main, when trying to DL open an SO file compiled from C3 on Linux. Right, so that's what we're trying to do. So let's start with this kind of thing. Excuse me? libc. Oh, it's empty. Okay. How can I do this kind of thing? So we can do something like this. So C3, maybe I'm gonna just do C3. So libc3 and file libc3. I don't really know. Maybe it makes sense to maybe pack it up. Right, maybe pack it up. So let's remove this kind of stuff and maybe this kind of stuff. Right. But I mean, it's actually super small. Right, let's actually try to do that. A file, literally an empty file. Right. We have 3 files. libc, then c file load c. Right. Something like this. Run sh. Let's also put load. When we run sh, when we do dash run sh, we get the following error. Console, and let me try to do something like that. Which is not something you would expect in this kind of situation, because we are talking about dynamic libraries. What main has anything to do with that? We suspect it has something to do with C3 linking the dynamic library with CRT10, which wants to have a main function or something like that. In any case, this really feels like a bug. Okay, so let's do something like my environment, something like this, console, So C3C version. So this is basically what we have. So, and maybe, yeah. NeoFetch. I also want to give NeoFetch. So I forgot about this. Oh shit, did it work? Oh fuck. So I didn't properly did the thing. Oh fuck. I don't know. Yeah, so it doesn't have enough spaces because those spaces are... Ah, yeah, I see. I see those spaces are not proper spaces. That's a bit annoying. Let me quickly try to fix that. We can try to fix that by doing something like this, where we grab that space and I suppose specifically in here we query replace the regular space with that space. Right, and because of that, this thing, I believe, is going... I apologize, this is so stupid. I'm too lazy to kind of fix it properly. So yeah, we're gonna leave it like that. Does it look good? Does it look? It doesn't look even good. Something about, yeah. I don't fucking know. Let's not do that. We already kind of mentioned that we're on Linux, so it's specifically a Linux thing. Right. So let's not be clowns this time. Right, I think it's good enough. So let's submit an issue. You removed spaces just now. Whatever. Okay. Doesn't matter. So we reported this kind of bug, and let's go ahead and continue doing things. As you can see, the language is not finished. The language is not finished, right? Because again, not that many people using it in all of these like different use cases and stuff like that. You really need to like actively use it to catch all of that. And also you need to report this kind of thing so the developers know that something is weird going on, right? So something is weird going on. Yep, so... Anyways, so let's go ahead and do the panim thingy. So we're gonna just basically always create this main function, right? So edit because of, and I can now refer to this thing. Okay, so reporting box is actually kind of useful thing because now, like I can put it in here and explain why this function even exists in here. Rena says generate O and do linking with GCC. Did he answer in here but he says to do that as a proper final solution or as a workaround. What is that? Is that a proper solution or is that a workaround? If that's a workaround, I can just create main function. So this is also a valid workaround. So yeah. Of flow responsibility onto someone else, link Jira bug, report the comment, the commit, the go. Yeah, exactly. I asked him, I figured workaround, I see. So it's a workaround. I have a different workaround. I can just create the main function. So that's also valid workaround. Right. So it's not a critical bug. It just like it feels like a bug, but it's not critical one. You can do a workaround. You can link it like you suggested, or you can just create this function. I don't think it's that big of a deal. But maybe I'm gonna keep this workaround like in mind, just in case this one doesn't work for whatever reason, right? Just because it compiles right now doesn't mean it's gonna stop working at some point, right? So it doesn't mean that it's gonna stop working at some point. It may stop working at some point. So anyways, I guess we can finally continue. You see, discovering bugs, reporting bugs, and stuff like that. Okay, so let me see. So now what I have to do, I have to create the rest of the things, right? So let's do knob, and let's do build panim, build libprob 2so, right? So it wants plug init. Let's go ahead and just create this thing, plug init. As far as I know, it has to have a very specific signature as well, plug init. There we go. So it has to have a very specific signature. What's that signature is going to be? Actually, it's nothing. It doesn't have any specific signature. I forgot about that. Anyways, right. So let's go ahead and just rebuild the whole thing like so. So pre-reload, we might as well actually copy paste all of these functions in here, right, and just create them. Right, I think it's gonna be fine. So boom, 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 I want you in my room. So also delete training white spaces, okay. So, what the fuck just happened, motherfucker? All right, so let's fucking go. And this is going to be, so all of these things are return values, if I'm not mistaken, right? Which is a bit annoying, because I can't easily move this thing to here, right? So because Emacs doesn't allow me to select it properly. But anyway, this one does return just void, like so. And in here, we can just do something like that. And in here, we can just do something like that. So in case of this stuff, we don't have to do any of that stuff. An environment, it's a structure, if I'm not mistaken, right? So we're passing this kind of thing by a structure. Let's not pass anything in here. So anyway, let's quickly define all of these functions. So this is going to be fn, like this. And I'm going to just copy paste that stuff. Export, like so. Yes, please. Boom. So we've got the functions. If I try to build them, so something is not working, missing return. Okay, so we can right away return true. So the engine will, let's actually not. Let's actually put false, right? So because it will constantly think that it's rendering things. Right, so this is basically the functions the engines expect the DLL to export. Right, so that's basically what it expects to see. Right, so, and if I try to do it now, okay, so missing return in reload. Reload, we're supposed to return something. Let's just return null in this specific case. And it worked. So that's pretty cool. It worked, didn't do anything, right? So because we didn't implement anything, but it did some things, right? So it did something, which is cool. I really like that. Okay. So essentially, plug init is going to be called once by the engine. So you initialize all of the stuff that you want to initialize. Let's go ahead and do that. So maybe we can just print something. Print fn. So let's put this kind of thing in here, and in here we're gonna say something like hello from C3 animation plugin, like so. Look at that, accidentally aligned. So now if I try to do something like that, right, I'm gonna close that. There we go. So this is the time at which the C3 animation plugin has been loaded. So yeah, that's pretty cool. Again, if you can create like a DLL that exports this function, you can work with this engine, right? So it's sort of like it's rather language agnostic. The only languages it can't work with is a toy scripting language, right? So because the scripting languages usually can't create a DLL by themselves, but actually you can, if you want to do like animations in a toy scripting language, you can take an interpreter of the toy scripting language, be that Python, JavaScript, or Lua, like any of these toy scripting languages. You can take its interpreter, compile it, yeah, exactly, Spiritman actually got the idea, compile it down to the DLL, also provide bindings for Raylib, And then not only you'll be able to use your toy scripting language in a serious engine for animations, but you can reuse the same DLL for different kind of scripts. So it becomes a plugin for several, animations written in different toy scripting languages. So you can do something like that. Maybe we can do that, by the way. We can write a single plugin for Lua. That sounds like a cool topic for another stream. Holy shit. That's a cool idea. I should try to do that. So, and then you can have several layers of hot reloading. You can hot reload the DLL of the animation, and the DLL of the animation that is interpreter of Lua can hot reload the Lua scripts. So you can have several layers of these things. That sounds really cool. Yeah, and what's funny is that it doesn't mean that you don't support native plugins. Right, so you can use both. You can do serious languages that's statically typed and compiled to real machine code, or you can do toy scripting languages, or like which are working with a single plugin, which is written in a serious programming language. Yeah, Lua actually would work great. So, yeah. That sounds like a cool idea. We're gonna do that. We're gonna do that, chat, but not today, not today. So people keep asking me, Zozin, how do you get ideas for your stream? They get born right on the stream, right? Out of my mind womb. Sorry. Anyway, let's continue. So we need to accept structures, actually, right? Because one of the things we do here is when you call plug updates. When you call plug update, so here's the plug.h. Plug update accepts environment as an argument. It's an environment of the engine. And what is environment, you may ask? It's a structure that looks roughly like this. So it's it has delta time, screen width, screen height, and whether you are currently rendering the video or not. Right, because the engine operates in two modes. The mode of preview, right, so when you're interacting in the window and stuff like that, and the mode when it renders the final MP4 video, right. And in that mode, it keeps still running your plugin, but it uses your plugin for generating frames to feed into FFmpeg. So an animation may know and act differently depending on whether you are in a rendering mode or not in a rendering mode. The reason being is that maybe the animations are written in native languages. So that means they can do whatever they want. For example, talk to the network. Technically, you can do that. It's kind of dumb, but technically you can do that. It's an arbitrary code. You can do whatever the fuck you want. But the animations, when you render a video, during rendering the frames, trying to access network or doing some weird stuff might not be what you want when rendering the final video. So to let the animation distinguish, okay, we're interacting with the user, and in that case, we can do something to make the user comfortable or some stuff like that, maybe additional inputs or whatnot. But when we're rendering, that doesn't make sense. So and because of that, you have additional flag where you can check, okay, so we're in a rendering mode, not in rendering mode, and so on and so forth. Makes sense? I think it makes sense, right? So because the plugins can actually provide bigger capability than just the engine. They can handle additional inputs because they work with the Raylib directly. So, and sometimes like when you render in the final video, you don't need those capabilities. In fact, they may prevent you from rendering the final video that you want to use in your video, in your YouTube video or something like that. Right, so this flag is actually kind of important. And play sound is an abstract method, right? Precisely for the same reason as we have a rendering, because we can be in two different modes, right? If you are in a preview mode, when you play a sound, it's going to be played through your dynamics or through headphones or whatever. But when you are rendering, play sound will be sending that signal to FFmpeg. So again, a little bit of a dispatching, a little bit of a polymorphism, right? So depending on the mode, it's going to just do different things. It's going to reroute the sound to different places. So that's basically the environment, right? The environment tells you where you are. Rendering environment, not rendering environment, and stuff like that. And the screen width, again, all right, so the renderer may just set a very specific resolution, and you have to do that within that resolution. So I suppose one thing we can do in here for specifically C3 is just put this thing in here like that. Just put this thing in here like that, and so sound wave. We're not going to be calling play sound, and I don't want to spend time figuring out like how to define sound from raylib and wave from raylib. So the thing I can do in here is just def play sound func, which is going to be just a func that simply returns void and doesn't accept anything. And in here we can say play sound func, play sound. There we go. And we're not going to be calling it right now. Right, so we're going to just acknowledge that this is a pointer to the function. We're not going to be calling it, right? So because you need to sort of like provide a correct signature, right? So to do signature to play off play sound func is incorrect, to save time. Right, so that's basically what we have here. And so now plug update, we're gonna accept the environment in here. So in an environment we have delta time, screen width, screen height, and so on and so forth. So yes, and funny enough now, if I do update, I might even print something on each individual frame, right? So C3 animation frame, and let's print delta time in here. So this is going to be fn environment delta time. So let's fucking go. Let's try to run this entire thing. Doesn't compile because semicolon. Boom. Okay, so, and it was, as you can see, it was successfully running and telling you correct delta time, except the first one. So with the first one, something was wrong, but we get delta time from raylib. So it's raylib who actually reported incorrect delta time, I think. All right, so it's just like when you rendering the first frame, you don't know what is the correct delta time. Okay, so the last thing we need to do is just link with the raylib, and we're Gucci, we're fucking Tamaguchi, we can do shit. So, all right, so let me acknowledge the subs. People been subscribing and I didn't notice that. So, DM1, thank you so much for telling me the message. C3 says no to DLL, you can too. Yeah. So iCodeBad, thank you so much for gifting the subs. Void Manager, thank you so much for your with the message. 2 years already, thank you for letting me participate in all the speedruns with all the joy and the frustration that comes with it. You're awesome, even when becoming really irritated with the chat. So yeah, thank you so much for the warm words. Halcyon, thank you so much for tier 1. Thank you. All right, so let's actually try to link this mother flipper with raylib. So there is this thing in C3. I think it's a vendor. And in the vendor, maybe I can steal some raylib scheiße. Oh, there's 2 separate things now for raylib. And which one do we use? I think we are still using raylib 5, or I'm pretty sure we're still using raylib 5. And I'm thinking maybe I can just like use this thing. Module raylib 5. Oh my god. Was it done recently or something? Wait. Is it recent? So when was it done? I didn't see it. 4 months ago. Okay, so okay. So it's understandable. So raylib 5. I suppose I'm gonna just steal this thing, right? So this is something that I was talking about, right? Like having like a raylib prefix would be nice. So I wonder if we can just like do it like that and just put it in here, wget, and yeah, let's just download this stuff. Did I download HTML? No, I didn't download HTML. Sometimes I forget to press row and it downloads the entire HTML, which is fucking annoying. But anyway, so in probe2, we want to import raylib 5 RL, and let's just try to do that. And it can't compile that because we need to specify that thing. So how are we going to be specifying? So this is the source. We might basically just do something like that. Build src, what was the source folder? I forgot. Aha, it's src dir slash raylib c3i. Okay, now will you please work? Okay, that's very cool. What's funny, I didn't even have to link anything because raylib is already automatically loaded by the engine. So yeah, it's already automatically loaded by the engine, so that means I can just do that? Really? RL draw rectangle. Okay, so let me actually open draw rectangle. Okay, so that means I can, I don't know, position 0, position that, 100, 100. Do you have something like red? Right, so it has to be RL red, RL draw rectangle. There's 2 of them. Another one from me. What if I offset this thing? Maybe there's something in here that this is just like a declarations, right? Double the font, exactly. This is just declaration. So there's nothing in here that may potentially link with another raylib library or something like that. I have a hypothesis that maybe I have to link my DLL with that raylib or something like that. Right, so let me take a look at the knob.c and how we create plugin C. Right, so we do position independent code. Right, so we also don't allow undefined and stuff like that. Maybe this is something that we also have to do, PIC. And also we have a libc function that, okay, so this one is rather interesting. So this is something that we probably have to pass to the compilers and stuff. So yeah, but I'm not 100% sure. So let's try to add this one to C3. Maybe that one is gonna actually do something, but it has to be more like Z in here, right? It has to be more like Z. So let me see. So what is it talking about? It didn't like, so minus Z is not, cannot process the unknown option ZR path. So minus Z, send argument as a parameter to the linker. But I mean, that's exactly what this does, because this is kind of similar to WL. Is that what she wants? No. Because WL is how you send the linker to Z. That's kind of a weird thing. So is display cleared? Okay, so what we need to do? We can try this thing with maybe compiling to O first and then using the linker, because maybe something is fucked up during linking raylib. Right, something is fucked up during linking the raylib. I feel like it is. Right, I think that it is. But I think I want to make a small break, right? So I need to refill my cup of tea. And after the small break, we're going to continue investigating and trying to figure out what exactly is with this stupid thing. Anyways, as you can see, I need some tea. Let's make some break. And we're back, motherfuckers! So we just realized that it was in fact because I was not clearing the background, right? My other plugins actually clean the background, so let's go ahead and do that. Yeah, where is my plugin? So prop 2, and I suppose what I have to do in here is a clear background. And what does it accept, by the way? Chat. Clear background. It accepts the color, and I suppose color is a structure. Understandable. The thing I can do in here, I think I can do something like 80, 80, 80, FF. Alright, so now let's try to run that, and there we go. A single rectangle. So it doesn't really, yeah, it just puts it at 0. Oh, because I have set it, right. So let's actually try to center this thing. I think it's gonna be kind of interesting. So we're gonna start with maybe X. Maybe I'm gonna even start with the floats. So essentially, in terms of width, it's gonna start at the half of the screen width, and we need to know the width or the size of the rectangle. So let's actually introduce something like a maybe size, right? So it's gonna be size 100, like so. We offset it by this half of the screen, and then we subtract half of the size, like so. So the same thing we do with Y. But with height. So, and in here we just use this X and Y, and here we just use size, like so. And it is going to actually center it, hopefully, but you have to explicitly cast it to an integer. Honestly, if I can write animations using C3, it's going to be more comfortable than using C. There we go, so it's centered. Look at that. Look at that beauty. Look at that beauty. That's pretty cool, I think. We can now maybe implement some simple animation that you can render, right, into MP4 or stuff like that. So let's try to render maybe a circle. So draw circle. I want something like this. So I want to implement like a circle that rotates around the center of the screen using a sine, right? And it just does one cycle, and that's going to be the end of the animation. So it basically smoothly loops, seamlessly loops, right? And then we're going to render MP4 out of that and see how it works. So this is the center, and the center is going to be actually located somewhere here, I suppose. But I suppose we need to have a radius, radius of the animation. So I need to come up with good names for the things, right? So essentially we're gonna have a center, right? So this is a center. Do I have an ability to draw Scheisse? Do I? Yeah, there we go. So this is the center. Then we have a circle, right? That is just going around that center. How do I call this thing? I think I'm gonna call it distance. See, I just self-prop orbit. Okay, that's another good name. Thank you so much. So this is orbit. And let's say that is going to be like a 500 or something. Or maybe we can even do something cool by making it relative to width, which is going to be essentially half of the width. Why not? That's a good thing. So in the center, so CX and CY is going to be like this, orbit. But since it's a radius, essentially, we don't have to divide it by 2, right? It's something like that. So this is the center. Well, I mean, it's just that then, right? So because it's just a center. And then we can have a radius of the circle, radius, which is going to be, I don't know, maybe tenth of this entire thing. This is something that I actually kind of stole from Jonathan Blow. Right, when he does UI interfaces and stuff like that, he always defines his parameters as fractions of the screen, width or height or some other stuff. And I think it's fucking cool. Right. So it's sort of like you have these independent measure units, right? And you kind of even explicitly write in them, right? So it's a tenth of the width of the screen. This is a half of the width of the screen, right? And it feels like working with CSS almost, but it's actually directly in the code, right? It's not a tenth, hundreds. I'm sorry. I don't have education, so I don't know math. All right. So whatever. So let's do CX. It doesn't matter if you know math or not. Computer doesn't give a shit about your knowledge. The program either works or it doesn't work. That's it. That's the only merit. You can say whatever stupid shit you want. Right, that's why I like programming, by the way. This is why I like programming. You can be as dumb as you want. You can say as dumb of the shit, incorrect, mathematically correct, as what doesn't fucking matter. You wrote some code, it works, you're right. You're a good programmer. What you say doesn't fucking matter. Mathematicians are molding. Mathematicians are molding. Blah, blah, blah. The code works. Code goes. You know what I'm talking about? You know what I'm talking about. So here's the radius, and here we're gonna just do a rel red. So that's what I'm doing. And so when I draw the circle, it wants to be this thingy. Maybe I can do V, so then I can do something like that. I think I can. So, and it's just where is the V? Yeah, so that seems to be good. The best motivation quote, exactly. Raidus! Raidus! Alright. Okay. That looks like shit. But this is just a center. Right, so we also need to keep track of the current sort of like angle. Or not even angle, but for how long the animation has been going. That's a very interesting thing. And because of that, we need to manage our state. Right, let's introduce the notion of the state. So here is the state. Here, I suppose we're gonna have like a global time, like so. And the way you're supposed to manage the state in Panim, by the way, you're supposed to have a global variable, right, which points at null. Right. So, and then when you are initialized, you're supposed to allocate that global state. Right. So you do new state like this. That's what you do. You just allocate a new thing. Why is it like that? Why is it like that? This is needed so you can reload the shit. So when the engine is about to reload your animation, you're supposed to return your state like this. So then the engine is going to remember your state. I can even show you that, by the way. Right, reload like this. You pressed H, we call the plugins pre-reload, and we take your state, we reload the plugin retaining the pointer to the state, and then we put that state of the previous plugin back into the new plugin. So essentially what you have to do in the post-reload, you have to take that old state and assign it as this state. That way, you do not lose a state between reloads of the plugin. Smart, isn't it? Right? So when you initialize, you allocate some memory. When it's time to reload, you give it away to the engine. Engine saves that pointer, reloading the plugin, give it to the new version of the plugin. So obviously, it doesn't allow you to modify the schema of the structure. Right, it's kind of difficult to do, but if you don't modify the schema of the structure and only modify the logic of the animation, it works fine actually. So especially useful when you're tweaking parameters, right? So maybe we're going to be tweaking some things in here, and hot reloading should be fine. So anyways, so that's basically what we're doing in here. So now we have a state, and now we can store global time in that state, and essentially we're gonna be updating the global time. So global time, state global time. We take environment and we just add the delta time to here. So we kind of need to know for how long we want to play our animation, right? So for how long a single cycle is going to go. A single cycle is going to go. Well, Lerner is already working on fixing issue. Lerner is absolutely great. He's one of the best developers I actually know. Right. So I think somebody asked me who are my favorite developers, and I said Jonathan Blow, George Hotz. Lerner is not one of my favorite developers, right? So he's so devoted to this project, right? So he understands that there is some shortcomings to the project, and he's eager to actually fix them. And this is something that I deeply respect. This is something that I absolutely deeply respect. To be fair, this is not a critical issue, right? He didn't have to work on it right now, right? Because we have a workaround. And I feel a little bit bad, right? So maybe I just put him on the spot. I'm sorry, Lerner, I didn't mean to. I was just doing recreational programming session. You don't have to fix it right away. We have a workaround, so you can take your time. So I really apologize for that. Didn't mean to put anybody on the spot, but yeah. Sometimes it happens. Anyways, so we need to figure out for how long we want to play our animation, right? So let's just say, not really animation, but the cycle, a single cycle animation, right? So let's say cycle duration, and it's going to be in seconds. Let's say that it's going to last for 1 second, right? So now, with the global time, we know how much time has passed since the beginning of the animation, right? And by the way, when we reset the animation, I suppose one of the things we want to do, we want to also reset the global time, right? So the animation is actually resetting here. So if we divide it by a single cycle, we get an interpolator which goes from 0 to 1, right? Which goes from 0 to 1. And then we can convert this thing to an angle from 2 pi, from 0 to 2 pi, and this is like the full cycle, essentially. Is that a good idea? I think it is a good idea. Right, so this is the angle. And now from that angle, we have to generate the actual position of the circle, right? So we have Cx, and we need to do something like Px. From Cx, we add math sine angle multiplied by orbit. And this one, it's not sine actually, it's a cosine. Y sine y orbit. So it's a px and py. This is px and this is py, and this is what gives us the thing that we want. All right, so it doesn't compile because why? There's no field global time, which is global time. Okay. All right, anything else? Sine, we probably need to import math. Is this std math? Is this std math? I think it is. And for the pi, I think it's something like this. Ooh, that's pretty cool. Now, chat, are you thinking what I'm thinking? Are you thinking what I'm thinking? So let's actually increase the radius of the circle. I'm gonna recompile this thing. All right, so I probably have to do that slightly differently. I have to run this entire thing as a sort of like a synchronous thing. So then later I can just rebuild the whole thing and hot reload it. So let's increase, like maybe increase the duration. Let's say that it should take 2 seconds to do this thing. So it's rotating a little bit slower, maybe even 3 seconds. Right, and let's go to the orbit and actually say that the orbit is going to be quarter of this whole thing. So we get something like that. Then in here, we can even now modify the color. We can do something like green, right, like this. So, and yeah, this is what I'm talking about, right? So this is, hot reloading capability is provided by the engine, right? So it's provided by the engine itself, which is rather cool, I think. Pretty cool, pretty cool, pretty cool. So yeah, C3 is not a toy scripting language. It's a serious, statically typed native language, and our engine is designed to work with these kind of languages. That's why it just works, right? So if you can create a DLL in your language, you can use your language with this engine. Why are you not lying on the bed? Isn't that the new meta? I need to think about my setup, right, if I want to actually stream from the bed. You know what I'm talking about? The bed stream soon, maybe, I don't know. So radius, let's actually increase the radius even more. Oh fuck, I didn't mean to render it actually, because it never finishes, by the way. I didn't create a finished, you know, condition so it would render indefinitely. So you have to be careful. We can create it though. So essentially it's literally kind of the same thing, right? You need to know the interpolator, and it's basically finished when the interpolator is greater or equal to 1. So that's going to be our finished condition, right? So we can hot reload, and now we can render the whole thing, right? So hopefully it's gonna, yeah, so it finished rendering, and we literally just created a video with this thing. Right, so I intentionally made it loop, and as you can see, it's looping, and it's actual video, so it's MP4, right? So this is basically Panim, right? It allows you to write these plugins that allow you to make procedural animations like that, and then it can render it to MP4 files and stuff like that. So I created this system in case in the future I want to make, you know, visualized videos and stuff like that. So, right. And I can show you my coolest animation that I made with Panim, right, if you're interested. So it's the one with the Turing machine, right, so libtm. It's this one. It's made with Panim in the style that I just showed you. Right. So it's literally programmed in, but in C, not in C3. Right. So it's just basically Turing machine. Small Turing machine. It's pretty cool. I think it's pretty cool. You can restart it. You can even stop it. And you can actually slow down. So we have delta time multiplier. So as you can see, it now going slower. So you can debug your animations if you want to. You can see exactly how they're played and stuff like that. So yeah. You have to be a little bit of an artist as well, right, to pull that out. But well, I mean, it's an old animation, so it still has expert content. So you can follow me there if you want to, right? But it's a shithole of a platform, unfortunately. So Yesu. So the thing is, I already spent 2 hours working on this entire thing, and I can conclude that C3 is suitable for writing animations for engine where we use C. I should replace it with Blue Sky. I don't really like Blue Sky's links. You know what I'm talking about? What the fuck is this link? Can anybody tell me? Is that like... Can I use this as a domain? Does it create domain like that? Oh, it does! Holy shit. Okay, so it actually creates a... I didn't know that. And, okay, and that's why... Yeah, so as far as I know, one of the features of Blue Sky is that you can have custom domains, right? So you can verify. I don't really know how to do that, but you can verify them. So that means you can create like another layer of domain of your personal website, right? So if I had something like a Soding, I don't know, something, soding.com, right? I could say bsky, verify that as a domain, and on my server, I could redirect to my Blue Sky or something like that. Is that how it's done? Is that how verification is done? Yeah, ping. Right. That's kind of interesting. Okay, I really kind of like this system, so I can probably replace .com. Unfortunately, there is a lot of like useful info on x.com. You know, there's also trash as well. I don't know. So, and it doesn't do anything to moderate that because it's all freedom of speech. Freedom of trash, I suppose. But anyway, so where is the TM? X.com. Right, so I'm gonna put that thing in here. So, and this is the libtm. So yeah, now it uses Sodium Blue Sky or whatnot. CRT10 in the chat? No. There's Control O, but not CRT10. Oh! It's a... I mean, come on. It's not that. So, it's cool and all, right? So C3 is usable in this regard, but something that C++ cannot survive is hot reloading the, the virtual functions. And this is something that is difficult to pull off, honestly. This is something that is difficult to pull off. We can now maybe introduce some tasks. We can go ahead and actually try to use the futures that we developed on the previous stream. Right, so let's go ahead and try to do that. C3 foot. Right, so here they are. People already submit pull requests. It's not finished yet, guys. It's not even finished yet. Right, so we have this interface and we can define our custom futures and whatnot. So let me download it raw. Just like I do your mama. Oh, I'm sorry. So let's download this thing in here. And knob.c. So I suppose what I want to do in here is C3 foot C3. It's actually just futures, right? So futures like this. Okay. And if I try to simply rebuild, it doesn't like what I'm doing in here because it's just a future. Okay, sure. There we go. So that seems to be working. So that means in prob2, I can now import future as well and use this future thingy. So what kind of things we can actually implement in there? Let's implement an interpolator task, right? Some sort of an interpolator task. This is going to be struct and it's going to be lerp, right? Some sort of like a linear interpolator. This is a linear interpolator. And it is going to store its current state, right? It is storing current state, or maybe a pointer of the value of some sort of a value that is currently, interpolating, right? So this is what it's doing. Learn already fixed the bug. I'm actually really curious how exactly he fixed it. So let's go. Let's actually see. So maybe we can even confirm that it's fixed as well. Okay, let's go ahead and verify it. Sure. So fix problem with 31 was linked. So there were several actual fixes. I'm really curious how exactly he did that. So fix problem with 30 was linked for dynamic libraries on Linux and BSD. So we didn't even distinguish whether we were building like a dynamic libraries or not dynamic libraries. In case of a dynamic library, we just don't include it. Okay, so that's sort of like a first approach that he took. Then there were some modifications, I suppose. Okay, he was probably fixing some of the tests in here. So another commit, kind of similar. So he's probably fixing tests and everything. Right. Nothing particular. So the main idea is probably just simply don't... Oh, and he also found some bugs with the macros, right? So because they were not... Oh, this is such a nasty bug. Damn. Do you guys see that? Right, you have several statements like that. And it was not wrapped into the do while. Do you guys know why it is bad? Do you guys know why it is bad? So I'm going to show you. So essentially, if you have something like a foo, and it has like f, g, and you just call foo, you expect both of them to work. But now imagine this. Or even like this, or some sort of a condition. Imagine what can happen. So this is why when you write in macros in C, if they have to do several statements, you wrap them in additional scope thingy, preferably do while, so you can do things like that. Why do while instead of just block? Look, if you just put the block in here, it may work for a while, I think. Right, so you're gonna have additional semicolon in here. But then, if you have something like foo else, you may not have a semicolon in here. So let me actually show you. All right, so I think it would be best to demonstrate that, because it's a very common question. So let's create a couple of functions in here. So this is gonna be printf, right, f, and so g, right, g. All right, so we don't really need to run it, we just need to compile it. But I mean, running it would be nice, because we'll be able to then see how it is working. So if I just do main.c and then run the whole thing, let's go to compilation errors. It just worked. All right, so but it would be nice to have new lines in here. Right, it would be nice to have new lines in here. So let's take a look at the original bug. So we have this. Then you want to disable the whole thing. You want to disable the whole thing. Right, and you probably need to have boolean. That's fine. Yeah, but you didn't disable. Only foo got disabled. Now the first logical thing. Okay, let's wrap it in scopes. Wrapped it in scopes. Everything's fine. But now, what if I try to put else in here when I try to do something else? You can't have semicolon between curly brace and else. You can't do this kind of thing. You can't. So, because this entire thing is not like a proper statement or anything, so the easiest way to fix that is to do while 0. And only then it works. That's why. It's stupid. I understand that. It's kind of stupid. And the problem is that it's so obscure and it's so unobvious that I have to answer this question every single fucking stream where I encounter that. I wish it was more obvious why it is like that, but I mean, it is what it is. Anyways, so let's go ahead and try to verify this entire stuff. So I'm gonna go to C3 and just fetch the latest thing. All right, and origin master. Let's go to build. And let's rebuild it with 10 threads. Okay, so the only modifications were in build options, linker, and compiler. So that means we actually fetch the latest thing. All right, so let's install the whole thing. Now let's try to reproduce the problem that we had. So panim. I need to download all of these files that I had in here. Right, so obviously I had empty. Oh, I already have it, I think, in here. So it's here it is. Here it is. Okay, so I can remove all of this stuff. Right, so, and it works fine. It works just fine. We can now go into C3C. Look into the previous commit, right? So because as you can see, there were several of them. Maybe even here, right? So here's the one. So this is one fix, this is another one. We're going back in time, rebuilding the previous version, Install it, go into the bug, running the bug. Bug is there. Very easy to reproduce, very easy to verify. Let's go back. Let's go to the master. All right, so make g10. And after that, make install. I just need to wait until it links everything. Bug. Everything works. C3C. So works on thank you so much for fixing it so quickly. Can we do, yeah. So let's close with comment. All right, so that's pretty cool. Prove that. Prove that C3 is going somewhere. It's going to take over the world. Zig and Odin are in shambles. I'm fucking telling you. Zig and Odin are in shambles. Thank you so much. All right, so that's pretty cool. That's pretty cool. So we have a working thingy in here. Try without specifying Linux CRT. That's a good question, actually. But I mean, that is already different bug, in my opinion. That is already kind of a different bug. But we can try to do that as well. So run. It works fine. Thank you. Guys, language keeps improving as you use it. Like literally in front of your eyes, it's getting better and better. You can see that. It's just like right in front of your eyes. It's just like it's magically becoming better and better and better. You don't even have to wait for releases or anything. It's amazing. I'm telling you. Can your Zig do that? Can your Odin do that? I don't fucking think so. Can your C do that? Motherfucking C can't even finally finalize the embed thingy. They still don't have it final. Maybe they still have it already have it finalized, but I don't really know. But I mean, it's so slow. This thing right in front of your eyes getting better. So, thank you so much. It's amazing, actually. It's amazing. Self-learning language, exactly. C needs a committee to add tiny feature that no one really needs. Yeah, exactly. What language are you working? I don't really work on any language, but I'm working with C3, right? So there's a C3 programming language, and we're just using that. So we're just exploring this language. We're testing it, right? So I'm essentially like a unpaid QA for C3, right? I'm just like doing random shit with this language, discovering new bugs, right? So, and potentially reporting them. There was a discussion in the C3 Discord about how enums should work. Yeah. So enums in C3 is a really painful topic for me because I understand what the designer was going for. I understand, and it's a good thing, right? Because you really want to associate enums with elements of certain array. And I suppose the intent was kind of formalize exactly that, but it just like turned out really weird. And maybe I just didn't get used to that, but it evokes so many emotions in me. I don't really know. So, because it's a very common thing, actually, that you have an enum, right? And then you kind of have a bunch of arrays, a bunch of tables that associate the elements of the enum, like in C it's usually like that, like count, fus, right? You have a bunch of tables, table 1, count, fus, and they are of different types, right? They are of different types and so on and so forth. Some of them maybe even structures, some sort of a structure, right? And you have all of these tables and you're constantly looking up different things. So foo, like 1, foo 2, foo 3, and so on and so forth. And you're constantly looking up certain things like that, right? I understand the intent, but strictly attaching all of these tables to definition of enumeration means that you can't comfortably have more tables potentially defined outside of the library where enum is defined. You see what I'm talking about? Like, I understand the intent, but the way syntactically and semantically it is implemented, first of all, it is confusing. Second of all, it's kind of restrictive. So it's just like, I understand, but the way it's done, it's kind of, I don't know. It's difficult, right? So, because if I'm trying to criticize this feature, I'm sort of criticizing the idea of associating enums with tables, but I'm really not. I'm just not fan of how exactly it's implemented. I think actually moving the associated arrays into the enum is a good idea because you can assert that the enums is continuous, but having, well, okay, that's a good point. but having separate stuff C-like would be good. Yeah, I see what you mean. It's this famous problem that enums can be sort of like a, you know, with holes, right? So because you can all of a sudden somewhere here you say, okay, this is 10 now, right? And so here was 0, 1, and suddenly 10. So the count is actually not 3, but it's like 12 all of a sudden, right? So there's enum flags, and enum array. Oh, there is also, oh, in Jai there is enum flags and enum array, or where? I'm actually really curious. Is that a Jai thing? So modules. I'm saying just like, oh, the idea, yeah. Huh. But yeah, I don't know. I don't know. So again, but it's not super critical, right? So it's not like it restricts you from doing anything, because you're just not forced to use that, right? So essentially what you can do is that you can just define an enum, right? I don't remember how you specify the underlying type, so something like that probably, right? And you can just like use it yourself, right? You can just use it yourself. Let's thumb up or something for learner. Okay, let me see. So what's up with that? What's that? Oh yeah. Let's give it thumbs up. That's true. Thank you so much. Okay, cool. He's doing God's work. All right. So let's go. Let's fucking go. So what I was doing, I wanted to see if C3 survives the hot reloading also with dynamic, with virtual table. I would suspect that it doesn't, right? So, because making it survive is actually a lot of work, right? And I doubt that any language designer actually will put that work. C++ doesn't give a shit, right? So, so yeah, let's see. I just want to try that nonetheless. Because it's a very specific case that is not the case for a lot of people, right? But I wonder, does C3 even allow you to do anything with its virtual table, even if it is virtual table, or is it something else? Does it allow you to just like inspect it or patch it up or some stuff like that? Because if it does, this is a game changer, honestly. That's already way better than C++. Because in C++, you just have a virtual table. You don't know what it is, but it's just there and you can't do anything with it, right? If you're doing some low-level hackery, low-level platform-specific hackery, good luck. Just straight up good luck. And different compilers on the same platform may generate completely different code for virtual tables. So it's not formalized in any way. It's all hidden from you. You're too dummy to know all of that. I hot reload my game code, but the entire state is on the XZ. Why would you want to keep the state of the DLL and so? Because the engine and DLL is separated, right? The engine is abstracted away from specific animations because we want to have just an engine and then the animations, right? Right, so, and we also hot reloading the code and stuff like that. So anyways, XZ. So, what we want to do in here, right, so let's go into the prop 2. So this is the lerp, and we are going towards the goal, right, so that's the goal value. We're usually going with a certain speed, right, so I didn't even know, right, so this is the sort of place that we're modifying, all right, this is sort of the place that we're modifying. Then this is from A to B. We're going from A to B. T is the current value, right? T is the current value. And the question is, for how long we're going? So duration. Yes, so that's basically what we're doing here. And this is a future, right? So by itself, this entire thing is a future. So what I'm thinking now is that we need to create a method. So let's actually let the compiler tell me what I have to create in here. Right, so let's go. So future is not fully implemented. That's, oh yeah, so it's already telling me. So it needs a poll method. If you take a look at this thing, so it's a poll. That's kind of the thing we need in here. Prob2. So in it's any data, it's a lerp. So here's the lerp, and we accept data, which can be anything. So any in C3 is equivalent to void star, but on top of being void star, it also stores a tag of the type it is currently containing. So the type of this thing is known at runtime, actually. It is known at runtime. This is actually a very cool type. I think Jai also has an any, which is kind of similar, right? It's a pointer plus a tag of the type, and it's generated automatically by the compiler, so you can sort of like inspect what kind of type it is, right? So it's very useful, honestly. It's very useful. And the way we can do that, we can store the lerp somewhere in here, right? So here is our animation that we're currently playing in here. And we can, as we update things in here like this, we can take the animation and we can poll it. But then poll needs a data, and as the data, we can just provide a pointer to the environment. Alex over thanks, thank you so much for your subscription. Thank you. Right, so this is basically what we're doing. Yeah, so we just keep polling it. And the lerp itself, right, as it polls, what are we doing here? We need to update its sort of like a place, right? So what we're going to be doing in here, we're just going to be doing self b minus self a, right? We are multiplying it by t. And that's basically the value. It's not particularly great in the sense that t is normalized. But we kind of need to transform it into seconds, right? So because we have a specific duration. So transform it to seconds. We need to, I suppose, multiply it by the duration, right? So here's the duration, right? And that's now transformed into seconds. Then we need to take data. So this one is an environment, right? So in environment, we have delta time, and we adding the seconds of the delta time to this thing, right? So, and then we need to normalize it back by dividing it by duration, and that gives us the new t, so to speak. So that gives us the new t. That's how we are updating it. So interestingly enough, if self t is greater or equal to 1, we need to stop the animation. Unfortunately, the animation is not stopped. Well, yeah. Since this thing is not returning anything, we have to... Can I just like return true? Is that possible for me to return true like that? Right, because it's any, but any is a pointer, right? But I can simply allocate this thing on the temporary memory. So let's just try to return true and see what the compiler will tell us. Okay, so anyway, after we updated this time, right, I'm going to do self b minus self a, and I'm going to just multiply it by self t. And that's the new value that we have to put into the place, like this, right? So we are updating this place. And after that, depending on whether we're done or not, we must return different things. We must either return true or new, because it's not finished yet. So yeah, any is used to indicate whether the future is finished or not. Right, if it's null, it's not finished. If it has something, it's finished. But when the future doesn't return anything, like it's unclear what exactly do we return to indicate that it's finished. Something that is not null, but what exactly? So can I just return like 1 in that case? We need to see. Let's actually try to compile and see what it's going to tell. So return int to any, you can't convert int to any. So I want to see how exactly do you do that. So any, are you okay? Any, are you okay? Are you okay? Any cast, okay. Optionally cast, any to int. All right. So there is a returns an option value of type if the any value loosely. Yeah, can I just like, man, I don't know. I can always just like a tclone null. So essentially tclone will allocate a pointer in a temporary memory and put null in there. So this thing is basically a pointer, but it's a pointer that points to a null pointer. Something like that. It's kind of stupid, but I mean, it might work, right? So it's kind of like a downside of the current future library. Right, so and in here, obviously, this one has to be self-t. Return self. That's not a bad idea. Yeah, so let's return self, I suppose, as an indicator. Yeah, that's not bad, I think. Thank you so much. Right, so now we have to switch env. Right, and if the case is environment, we just do that. Right, otherwise we can say this is unreachable. Something like that, because we expect specifically environment in here. So what does it want in here? Anim poll. Okay, so it can fail. Ooh, this one is interesting. So this can fail, but we don't fail. We know that we don't fail, so we're gonna actually unwrap it. Oh, you can also do these kind of things, right? And it's not like we are going to dereference that pointer or anything. We just need to have something that is not null. Right, so that's, yeah, okay, so that seems to be like a working strategy, I suppose. Right, so this is like a really bad part of this interface, which I'm not a huge fan of, but I mean, it is what it is. So anyways, so we need like kind of a way to construct a thing. So how we're going to be constructing? So let's create maybe macro, maybe function should be enough. So this is going to be a future. Right, so lerp, let's call it lerp. And it's going to accept things like A, B, and duration, right? So you want to move things from one place to another one, right? So that's what you want to do. So, and what we're going to be doing, we're going to be constructing a future out of that, right? So this is going to be A, B, duration, and you also have to specify the place, like, because we're setting that place in here. So this is going to be place, like so. All right, so is it going to work? And if I go the semicolon, that's fine. That is totally fine. And this is not future, this is lerp, right? There we go, that seems to be working. I really like this clone idea, where you can just take a value and put it onto an allocator or heap or anything and just instantly get a pointer of that. I think Rust has something similar, but I really like it. It just makes it easier, right? So, yeah, I really like it. So anyways, here we're just doing poll, right? We're just doing poll. And I suppose we can just use the value of the t in here. So let's, in a state, where is the state? We're gonna have this thing, which is gonna be t, right? And in plugin init, we are creating anim, right? So the current anim, and we do lerp. We take a pointer to the state of t, right? So it's a pointer to the state of t, and we're modifying it from 0 to, I don't know, to 1 during, so there was a duration, right? So cycle duration, during the cycle duration. So that's what we're creating in here. That's what we're creating here. So we're lerping this specific value from 0 to 1 during the cycle duration. So that's what we're doing essentially. Okay, all right. And now instead of using t, this t, what we're going to be doing, we're going to be using state t, like this. Right, and that state t is animated by this thing. You see? It's animated by this thing. So now, if I try to rebuild, everything is rebuilding. So now if I try to run this entire stuff, it is animated and it's finished a single cycle. So it finished a single cycle. Here's an interesting thing. We can do a different kind of lerp. So plug init. So what if we now lerp from 1 to 0? Right, what if we look from 1 to 0? It's going to be moving probably in a different direction. Now it is moving in a different direction. And it stops. And by the way, we can even do something interesting in here. The way we checked whether it's finished or not. Yeah, it's finished when this animation is finished. And that means we have to do something like that. Finished, not equal to null, actually. What a goofy language. And I'm saying that without any bad intent, right? I'm saying that without any bad intent. It's goofy. It's goofy in a good way. Anyways, so if it's not finished, yeah. So as soon as it finished, it returned that. And that finished could be part of the state, right? So struct state, finished. And when we check in whether it's finished, we just returned finished. And when you reset, we do state finished false. So that's how we're going to be doing that. And when we reset, by the way, we also have to reset this kind of thing, I suppose. So that's how we reset things. Honestly, since we are doing the futures and stuff like that, I think global time is not needed anymore. Right, so let's go to the compilation errors. So error, so it says 78, no need to do that. And a 95, no need to do that as well. Right, so when we're doing that, we're leaking a little bit of a memory in the temporary allocator, but who cares? Right, so we have a lot of memory, we have 16 gigabytes. Just buy more RAM, stop being poor. Anyways, what I wanted actually, I wanted to have another future, which is sort of like a sequential future. Let's implement that. So it takes several futures and just sequentially executes them. That's what I wanted. So let's have struct sec. And in here, we're going to have essentially a bunch of futures, right? So futures, and also maybe an index, which one we're currently working with, right? Yeah, so where is the poll? I'm gonna grab this thing. So this is a sec, and if the index is greater than the futures len, that's instantly, it's finished, right? So we can return self. If it's not finished, what we do, we just take the current feature in here. So here's the current feature, and we poll it with this environment. We just poll it. And if this thing has returned something, right? So we probably want to do something like that. And if it returns something, we essentially increment this thing, right? We essentially increment this thing. And after that, we have to check this thing one more time, right? We have to check this thing one more time, and otherwise return null, right? So did we run out of futures? It's done. We didn't. We poll the current one. If the current one is done, we increment the index. Did we run out of features this time? We didn't, okay, this is not finished. So that's basically what it is, right? That's basically what it is. And in here, we're gonna create a constructor, right? So it's gonna be future, just sec, and it's going to accept basically futures in here, just a bunch of futures. And we can simply return tclone, sec, futures, this is several of them, futures, like this. Is it compiled? Forgot a semicolon. All right. What do we want? Futures, because this is self. Forgot about the self. Something to do using would be kind of great, I think. Something to do using. So tclone. Aha. So where's the tclone? Cannot explicitly because it's not implemented. So this is future. All right. Cool. So we have a sequence. Why do we need that? Why do we need that? Because now when we do init, what we can do actually is sequence. I wonder if I can do something like this. So you go from 0 to 1 and from 1 to 0, but this time twice as fast. So it's gonna be, or maybe like 4 times as fast. So that's pretty cool. So we have combinations of these asynchronous tasks. That's what we have in here, a combination of these asynchronous tasks. All right, so if I try to run this entire thing and it out of bounds, nice one. I think I know what exactly happened. It's something with secpol, yeah. Well, at least this is actually kind of great. It tells us where exactly we did the fucky wacky. So it was a 53. Okay, that's pretty cool. So what does it say exactly? Source unavailable, something, something. No zero init, maybe. I don't freaking know, but I think self parameter like self in Python. Yeah, I guess. But you can actually call it whatever you want. So I can call it your mom, for instance. And it's going to work. Can your Python do that? I don't fucking think so. I don't fucking think so. You can just call it whatever. So self-index in the cons. Cons? What the fuck is cons? Anyways, so I don't think it is out of bounds because I would expect the sec to be like this thing should zero initialize it. I think this thing should zero initialize it. My hypothesis, by the way, my hypothesis is that the futures themselves are not correct. So when you do plug init, where this array is defined, it's a temporary array. It exists only for the for this specific statement. That's probably why. But at the same time, like, I don't know. Is this how you do that? Again, it's a temporary array. That's kind of the problem. So for how long does it exist? I don't know. It's kind of bizarre. It's kind of bizarre. One thing you can do is to just have a list. But it's dumb. Can I tclone it as well? Something like that. Untyped this can be can only have constant elements. Untyped list, untyped list, untyped list. Okay, so what if I do it's a future? Yeah, so it's just a slice. And now it's a pointer. And I want to dereference that pointer. Okay, so what if I dereference that pointer? Yeah, so I feel like that's the thing. Is that it's it was not located anywhere, right? So, and I feel like I also have to do something like this. Conversion from array. Yeah, that's the thing. So by putting star in here, I mean that this is an array of the size of the amount of elements. This is how I understand it, at least. Right. So that means it will take and allocate enough memory for this entire array, and it will return us a pointer to the type of future2 array. So basically star means that the exact number here is going to be taken automatically by the compiler. Right, and since it's a pointer to this specific array, it can be automatically casted to any or a pointer of the interface or anything like that, or a slice, right? So in case of sec, it accepts a slice. Pointer to an array can be automatically casted to slice. That's why it worked. If I understand C3 correctly, this could work. If I understand C correctly, because I don't know all of the nuances, but I think it makes sense. I think this entire stuff makes sense, actually. That's pretty cool. That's pretty cool. Anyways, right, so let's try to run that. And I was right. And it, it crashed anyway, right? So it crashed anyway, but that's already a different problem. That's already a different problem, so it's 54. But it worked, so that means I understood the problem correctly. Right. So prob to 54, just equals. So, but that's already a different problem again. We might as well actually combine those things together. Look at that. Look at this nice code. Look at this nice mother flipping code. So, yeah. We can introduce some shit in here, like sec finished, finished your mom, and basically just move this entire thing there, right? And that will enable us to your mom finished. If your mom finished, return your mom. You see, it's that fucking easy. If your mom finished, return your mom. All right, look at that chat, look at that chat. Absolutely fucking epic. Render this shit. Render this shit. It's done. Looking at the MP4. This is MP4, and it's just like pew. It didn't finish. I know why. Because we didn't do that in a reset. So we have a duplicate code. We have a little bit of a duplicate code, chat. Plug in it. So we can do something like, I don't know, what, reset anim. Right, where we do this kind of thing. Right, so we reset anim. And this is where we can actually clean up the animation and stuff, right? But in any case, so here is the reset anim, and in here we also do a reset anim, right? It will just reconstruct the tree of the tasks one more time, right? Reset anim. So it's a sequential thing, and again, I can actually like add more things in here, right? So now I can combine these tasks together, right? So that's what I can do. I can combine them together. Now it's very easy for me to add another, you know, circle moving around and stuff like that, right? So it should be super easy. Okay, so if I try to run that, it seems to be working, and goes back. I do reset. So, and I feel like if you do reset, you have to clean up the temporary allocator completely, right? You have to clean it up because like all of that stuff is not needed anymore, right? So you can actually quite safely like remove all of that stuff. Okay, makes sense to me. So now let's try to add another circle in there. Let's try to add another circle in there. So we have in the state, where is the state? Struct state. We have T, and this is the state of the animation of one circle. Let's actually introduce something like T1 and T2, right? And those are going to be the sort of state of the animations of two separate circles, right? So let's go to the compilation errors. Let's go to the compilation errors, and obviously we renamed something, so it's not going to work. So that means here we're modifying this thing. We want to do a similar thing for the second one, also sequentially, right? But we don't have a second root task. we have to place these two things in parallel, like so. So we need to create a thing that allows us to play those things in parallel. Excuse me. Oh my god. All right. And it's also going to be a future that doesn't pull them sequentially, but it pulls them simultaneously all at once. You see what I'm talking about? Right, so something like that. And I suppose it's kind of similar in terms of like how we allocate memory for it. We just do tclone. And doing that tclone thingy is kind of tedious. So I think we'll have to kind of somehow tuck it behind the constructors and stuff like that. Right. So, but in any case, let's go to the struct sec. And let's introduce parallel sec. Parallel, and we don't need an index in here because we're going to be actually going through all of them. So let's take the poll. So this is parallel, and we don't need that. So what we do, we just iterate each individual future. Your mom futures. So we're going to take it by a pointer, like so. And we just poll them all, right? So future poll with an environment. So, and it may fail, obviously. And then if it is not finished, right, if it's equal to null, we should probably have some sort of a variable called finished, which is initially true, but as soon as you encounter one future that is not finished, you say, okay, this is not finished, and that's what you return. Right, so that's how you run them in parallel. Your mom variable, I mean, it's basically self, right? It's this or self or something like that. I called it your mom just to demonstrate that you can call it anything, right? So somebody asked it in the chat, so now I keep demonstrating because they said, ew, it's like Python. For me, the syntax is the language. I don't separate syntax and semantic. So to help out these kind of people, I'm now calling self your mom, right? So in some places we actually use self, like in here, but in here we use your mom. So, and yeah, we have to return null, right? If finished, return your mom, otherwise return null. Something like that, right? So that's what we're doing in here, my friend. That's what we're doing. Anyway, so now we have to create a constructor, right? And it's similar, right? It's kind of similar. So let's fucking go. Parallel, so futures and stuff like that. So state t, 137, that's what I'm talking about. So let's actually factor out this entire stuff into separate function because we're going to be drawing several circles. Let's create a function something like orbit circle, where we're going to be actually putting all of that stuff. So I think clearing the background has to be the first thing. Then t should be a parameter. T must be a parameter, like this. And let's move this entire stuff in here. So we orbit in the circle, something like that. So here is t. And we also apparently need an environment. So that's totally fine. Yep. So orbit circle environment state t1, and then we're going to have state t2. I also want to be able to customize the orbit and the radius, right? So because of that, I'm going to take it away, right, and I'm going to put them in here, and so this becomes radius and orbit, and we're going to accept them as a parameters. Float radius and orbit. And I think another thing I also want to customize is the color. Right, I want to have different colors for these things. So this is the color, put it like that, and this becomes a color. So then later I can actually assign different parameters for those things. So radius for a second circle is going to be, I think, smaller. Let's actually say it's 2. The orbit is going to be kind of closer. I think it's going to be like 10, and it's going to be red, right? So it's going to be red like this. So in here, I think that's about it. That's about it. So let's try to compile this entire thing. It doesn't like something in here because I forgot to define a color. Okay, so that's what we have in here. What else do we have in here? Expected 3 arguments in here. 3 more arguments. Didn't I provide it? Okay, yeah, so I have to do radius, orbit, color, like this. All right, that's cool. And when we do reset anim, so that's what we're doing. We're running these two things in in parallel. The thing I want to do with the second one is that I want to run from 0 to 1 twice as long as the duration, or maybe actually for as long as this thing. So I'm going to sum up this thing and this thing. So the second one is going to be slower and closest to the center, right? And these two things is going to go for as long as this entire full cycle of the second circle. And all of that has to happen simultaneously, right? All of that has to happen simultaneously. Okay, so let's fucking go. And it does nothing. So the second is not drawn at all. Did we use parallel? I think I know what is going on. Yeah. Copy pasting. Be careful when you copy paste, right? So now it should happen in parallel. Asynchronous programming. By the way, asynchronous programming, telling you. So that's actually kind of cool. So yeah, so you can combine them together, and it's just like, and then you can render it if you want to. So let's make a video out of that, MP4 video, right? So and let's just open it up, and this is a video, MP4, by the way, MP4. Very cool. And again, so this engine didn't know what language the plugins will be written in, right? Is that a mother flippin' C4 joke? Oh, 14 times! C4 jokes maxing. C4. We need to get to 100. It's a very creative joke. It's a very this joke is a blast. Holy shit. C4 maxing. So anyways. This joke is a fucking blast, bro. I'm telling you. So, the real thing in here, we can even actually make like a forever future that resets the future constantly. As it's finished, it resets it. But we don't have a reset in the interface of the future, so it may not work that easily. But anyways, we can actually reset, you know, manually, I think. If we do something like that, right? So I have, yeah, I can just press Q. Every time it leaks a little bit of a memory, but this is because we don't clean the temporary allocator, but it's not that big of a deal, honestly. This is a really cool animation. I really like it. So let me try to do hot reloading. Right. Let me try to do hot reloading. Will the hot reloading work? Right, because this is something that C++ can't do. And I honestly expect that C3 can't do that either. Right, because it's just generally too difficult to do it like that. So for instance, I want to change the color. I want the green one to be blue. Right. So what I do is I recompile this entire thing and I hot reload it. And it crashed. Right. So that's understandable. Yeah, it's a yeah. That's cool. That's cool. That's cool. So the reason why, right, is that I think it depends on how virtual tables are implemented in there. It just like very much depends on how virtual tables are implemented. And we have in a state, right, in a state, we have this future, which is a sort of like a typed pointer, right? And somewhere there, it probably generates a virtual table. And within this pointer, it also stores, yeah, it also stores the pointer to the virtual table. But since we reloaded the whole thing, we reloaded the whole thing, the pointer to the virtual table is now invalid. So you try to dereference that pointer to the virtual table, and you get nothing, right? So because as you reload it, the virtual table is just moving around in the memory. You can't really find it anymore. So, and it's the same with C++. C++ can't hot reload that either. And in C++, we were theorizing how would you even do that. Like you probably need to patch something within the virtual table. And the virtual table itself in C3 probably not even exposed or anything like that. So I don't even know how to fix that in C3. So in C, in pure C, how we do that is that instead of these virtual methods, we actually use enumerations. And a specific function that you need to call, specific polymorphic function, is actually indexed within that table. So when the plugin gets reloaded, the index within that table stays valid even though the table itself moves in the memory. So we solve that by actually exposing this virtual table that we coded manually to the programmer so they can patch it up, or not even patch it up, but just like refer to the elements of that table as an index. So that's one way to do that. And like I don't expect languages to actually provide this kind of functionality because nobody really does that. But if there were languages that do that, that would be actually kind of cool. Right. Does anybody know, do we have like a professional C3 developers? Is there any API that exposes the virtual table that C3 uses? Or maybe it's not a virtual table, but something. Like, can I have an access to these, like to the exact implementation of these dynamic methods and stuff like that? Or is it all obscure and hidden from the programmer? Because I feel like if C3 actually allow you to do this kind of stuff, it would be extremely useful. But I don't know. So there's a reflection, I remember. Ask GPT. Yeah. Sure. C3 allows both compile time and runtime reflection. During compile time, the type information may be directly used as compile time constant. The same data is then available dynamically at runtime. Okay. Compile time properties. So you have a line of associated element x name of members of is rather interesting. Parent of params size of values. Okay. Inner. So they return the type ID of an inner type. So things like array, bit struct. Kinda. Members of only available for bit structs. Okay. Names of returns the names. Oh, this one is cool. This one's cool actually. Params of. Parameters. So you can have. Ooh, this one is cool actually. So you can. That's a very cool level of reflection, and it's compile time as well. So I can do that at runtime and compile time. Right, at compile time I can just like take the type of the first argument of. What a based language, honestly. What a based language. Yeah. Compile time function. But nothing about dynamic, I suppose. Right, so yeah, the word dynamic only, like, you know, occurs only in here. Yeah. It's pretty cool. So my verdict. You definitely can use C3 instead of C++. But instead of C, right, in C we had to implement our own sort of virtual table, right? And until you can kind of like control the way the dynamic is done, I don't think it can really replace C. Right, I think there should be a standardized way to modify the virtual table stuff, the internal representation of the virtual table and whatnot. But again, not many languages do that at all. So I don't know. I don't know. All right. It's useful. It's useful. So I suppose all the C3 developers kind of left the chat, so nobody really knows if you can have an access to that internal virtual table of C3 or not. So yeah, we'll see. I'll try to explore that, and maybe if I find something interesting, I'll do a separate video on that. To be fair, surely you could also implement your own vtables in C3 or C++ if you wish. I guess in that sense you can say that both C3 and C++ are kind of like C in that regard. But yeah. But I just wish if they exposed how they internally worked. The error message pointed to internal code files. Oh, I didn't notice that. So let's actually take a look at that. Oh. So do I still have it? Or do I have to reproduce that? Nah, I have to reproduce that. Okay. So let's see. So this is knob. Oh, I probably have it somewhere here. Yeah, okay. So it's a built-in. It's not really internal ones. They are not internal. These are standard library. This is just standard library. So it's the point to print backstrace, to the point to the code that actually generated this entire thing. Structs file system file. Huh? Struct what? Or go to, oh yeah, I didn't read your previous message. Or go to the Linux way and make your own vtables. Okay, oh okay, I see. So I only saw the struct file system type message and didn't see the previous one. Anyway, I guess that was fun. So thank you so much for all the subscriptions. Alex over 6, thank you. Have a good one, and I see you all in the next recreation program session with Ahu and Mr. Azuzin. All right, love you. Mwah.